Alright, hello everyone. So, in this section 1.4 of Precalculus, we're going to do the following, right? So the domain and range, or the domain of an algebraic expression, simplifying rational expressions, multiplying and dividing rational expressions, adding and subtracting rational expressions, compound fractions, and rationalizing the denominator or the numerator and avoiding common errors. Okay, so the first thing that they go over in this section is finding the domain of an expression, right? Now, they want to find the domain of these expressions. So basically, we have these three expressions. The domain, so let me go ahead and give me 1 second, guys. Okay, so the first one that we look at here is 2x squared plus 3x minus 1, right? And of course they would, this is in set builder notation. Of course the domain is all the x values of an expression, right, or a function. So if we look at 2x squared plus 3x minus 1, the domain, so one thing that we should notice about this is that the domain, or rather this graph, represents a parabola, right? And it doesn't have to exactly match the equation, but it's just a what is it called? A sketch, a rough sketch of the function. So, one thing to notice is that yes, it's a parabola, and when we have a parabola, we want to make sure that, so basically any parabola, if we have f of x equals x squared, for example, the domain of any quadratic function, domain will always be all real numbers. And if they ask you to do it in set builder notation, you would say x such that x is an element of all real numbers. And yes, this is like a C, but it's like kind of like an E. And this is like an R, but it's with a 2. It's like with 2, like this. Okay. Or you can write it in and you would put brackets, right? Or you can write it in interval notation. You can say that the domain is from negative infinity to infinity, right? That would be the domain of this function. Now, the part B says x over x squared plus 5x, or minus 5x plus 6, excuse me. So find the domain, right? Now remember when I said that if it is a rational function, then if it's a rational function, then that means that the domain is, so if we have ax plus b over cx plus d, then that means that the domain is all real, such that cx plus d does not equal 0. So, in reality, yes, this would be all real numbers, but you have to set x squared minus 5x plus 6 not equal to 0, and solve for x, and you can factor out. So if you factor, you have 8 times c is 6, and then you have negative 5, and then two numbers that multiply to 6 and add to negative 5 are negative 3 and negative 2. So it'd be x minus 3 times x plus 2, or x minus 2, excuse me, does not equal 0. You can use the zero product property, saying x minus 3 does not equal 0, or x minus 2 does not equal 0. And then you can say that plus 3 on both sides, x does not equal 3, and then x does not equal 2. So the domain would be the following. Negative infinity, it would be from negative infinity to positive 2, because you have to go from lowest to highest, not including 2, so you put a parentheses. And then you put a union. This union symbol says that it is joined with another interval. Union, and then it would be parentheses, because you're not including 2, and there would be 2 to infinity, right? Now, one thing that basically, you know, one thing that I don't recommend that you do is say negative infinity to, I don't know, to like 0, and then do like bracket, and then do union 0 to 2, and then union 2 to infinity. Like, you don't have to do that, because the only thing you want to do... Oh, and by the way, it would be from 2... Actually, hold on. It would be from 2 to 3, and then union 3 to infinity. So like this. You always want to do, and if it helps, you can draw a number line, right? And you can draw like endpoints at x equals 2, and then at x equals 3. So it goes from negative infinity to 2, 2 to 3, and then 3 to infinity. That way you know that this is negative infinity, and then obviously here's 2, and then here's 3, and then over here is infinity, right? So then knowing this, you can just write it using this method, right? That's the domain. What I was going to say was, you don't want to write like negative infinity to negative 5 union, negative 5 to 2 union, da da da, because just look at your endpoints. Look at these two numbers specifically, okay? Do not include more numbers than you need to for the domain, because that's going to make it, it's just going to make it really, it's going to make your answer really like weird, and you're going to put more than, like, you're going to put more than it needs to, and yeah, no. You don't want to do that. All right, so part C says the square root of x over x minus 5, and you want to find the domain, right? Now, this is a very special one, and I say that because, number one, if you look at the square root of x, let's say that we plug in negative 1, right? Do we know what the square root of negative 1 is? No. So the square root of a negative cannot happen. So first, what we have to do is we have to set the square root of x over x minus 5 greater than or equal to 0. This will give us square root of x greater than or equal to 0. We square both sides, we get x is greater than or equal to 0. And then the bottom part, we have to say x minus 5 cannot equal 0, right? So we have to say that these are the restrictions, by the way. You have to state the restrictions. X does not equal 5. So these are the two restrictions that we have. It has to be all real numbers such that x is greater than or equal to 0 and x does not equal 5, right? So if you think about it, you cannot include negatives, okay? So in reality, it would be the endpoint at 0, and then the endpoint at 5, right? And it says it cannot be negative, right? So you're not going to shade the negative part to the left of 0 because that's a negative. But you're going to put that yes, we are including 0, but we're not including 5. It's an open circle there. So in reality, it would go from 0 to 5, but also know that it can also be greater than 5 as long as it does not equal 5, right? So we can say that if you can plug in numbers, you can say that the square root of, for example, the square root of 6 over 6 minus 5, that's just the square root of 6 over 1, which is the square root of 6. So yes, if we put a 6 here, yes, it'll be included. So we can also shade that part. Okay. So in reality, in interval notation, the domain will be, since we're including 0, we're going to say bracket 0 to 5, parentheses, and then union 5 to infinity with a parentheses because we're not including 5 at all. Okay. I mean, in reality, yes, they did it in set builder notation, but you can also rewrite this in interval notation if you wanted to. Okay. Simplifying rational expressions by canceling out, or by cancellation. One of the things that they're teaching here is saying AC over BC is A over B. That's true because you can cross this out and you can say that it's equal to A over B. So the reason why they teach that is because, so let me just go ahead and so let's do this one, okay? X squared minus 1, we can use the product of two squares or the difference of two squares pattern. This is just equal to x plus 1 times x minus 1. And then divided by, and you can always use box method to factor top and bottom, it's okay. But the bottom would just be x plus, so it would be x plus 2 times x minus 1, right? So simplifying, notice how we have these two expressions. That's why they told us that a b over AC, or rather, what did they say? They said AC over BC. Give me 1 second, guys. Okay, AC over BC. This cancels out. This equals A over B. The reason why they say that is because in reality this is A, this is B, and then this is, this is A, and then this is C, and this is B, and this is C. These two cancel out, so in reality we're left with A over B, and A equals x plus 1, and B is x plus 2, right? That's why they were giving us this expression here. So like they did, they factored the top and the bottom, and they put x plus 1 over x plus 2. Okay, so it says multiplying rational expressions, right? Anytime we have A over B times C over D, that's just going to be, you're just going to bring it together, AC over BD, right? So example 3. Now, also remember, though, that you don't just have to remember this, but also remember what you previously learned. So this as well. Keep this in mind. Keep this in mind as well, because you know, like I said, you don't want to just know this and then, you know, only apply this rule to the following problem that we're about to do right now. So, knowing that AC, so I'm just going to do this in a different way. AC over BC equals A over B. Keep this in mind, and also keep in mind that A over B times C over D is AC over BD, right? Keep this in mind. Now let's look at the following problem. We have x squared plus 2x minus 3 over x squared plus 8x plus 16 times 3x plus 12 over x minus 1. Now, the one thing that I really, really recommend that you guys do is when you look at these, you want to make sure that any of these are factorable, okay? So you always want to do that, even for division, which in division we'll look at it in a few minutes, but for now we're looking at multiplication. So we have x squared plus 2x minus 3, and then we have x squared plus 8x plus 16, and then we also have 3x plus 12, and then we also have x minus 1, which x minus 1, it's a factor. We can't factor it any further. So the ones that we mostly want to focus are the previous ones, right? So let's factor x squared plus 2x minus 3. In reality, this is equal to x squared plus 2x minus 3 times 3x plus 12 over x squared plus 8x plus 16 times x minus 1. However, you want to make sure, because if you just multiply it across like this, you're probably going to get it wrong, because you want to make sure that any of these are factorable first, so that when you do multiply it out, you can multiply out the terms and then you can cancel out, right? You want to make sure that first that nothing cancels out. So to factor this one, it's just 1 times negative 3, that's negative 3, so two numbers that multiply to negative 3 and add to 2, are x plus 3 times x minus 1. So this would be going over here, and then x squared plus 8x plus 16, that's just x plus 4, two numbers that add to 4 and multiply to 16 are 4 and 4, right? And then 3x plus 12 would just be 3 times the quantity x plus 4. And then x minus 1 is just x minus 1, right? So you want to go ahead and apply these rules to all of these ones, right? Okay, so rewriting this, we're going to have the following. The following rational expression. So we have x plus 3 times x minus 1 over, and then we have x plus 4 times x plus 4, and then times, and then we're going to have 3 times x plus 4 over x minus 1. Now bringing this all together, we have x plus 3 times x minus 1, and then times 3 times x plus 4 over x plus 4 times x plus 4 times x minus 1. Now, notice the following common terms. We have x plus 4, we also have x minus 1 and x minus 1. So we can go ahead and cross those out, right? Okay, and then we are just left with 3 times x plus 3 over x plus 4, right? So we have now you can leave it like this, or you can also simplify it and say that this is 3x plus 9 over x plus 4. Either way, it's correct. Yeah, so this is how they wrote it. I mean, you can, it always just helps if you factor it and you just do it like this, right? But you can also do it this way, as long as you kind of know the difference between both, and or actually know how to put both answers. I always like to put both answers in case the professor looks for the factored form or the combined form. But yeah. Okay, so dividing rational expressions. Dividing rational expressions is different. When we have a over b divided by c over d, we have a over b, and then we multiply, change the division to multiplication, times, and then we flip the fraction d over c. So this is just like when you did fractions, right? You would say 1/2 times 4/3, and then this would be 4 over 6, and then you would say, oh, this is 2 times 2 over 2 times 3, so then it would be 2/3. It's very similar with algebra, right? And we already did these, you did these in college algebra, obviously, so we're briefly just going to go over this. We have x minus 4 over x squared minus 4, and then we have x squared minus 3x minus 4 over, and then we have x squared plus 5x plus 6, right? So again, what you want to make sure is that you factor top and bottom for all of them, right? However, keep it as a, I mean, unless you want to go ahead and get rid of the division symbol right away, then you can. But make sure that you flip this over when you do that, okay? And also make sure that you're doing multiplication. I always like to just, factor first and then do the flipping over. But it's really your choice. So we have x minus 4, and then x squared minus 4, that's just x quantity squared minus 2 quantity squared. That's just a squared minus b squared, so it's going to be x minus 2 times x plus 2. You can use Xbox method if that helps. So we have x minus 2 times x plus 2, and then we have divided by, and then x squared minus 3x minus 4. Well, two numbers that multiply to negative 4 and add to negative 3 are negative 4 and 1, right? Divided by, and then x squared plus 5x plus 6, that's just x plus 3 times x plus 2, right? So then we have x minus 4 over x minus 2 times x plus 2 divided by x minus 4. So basically, this is what we get, right? This is the division that we get. Now, we can apply the dividing fractions rule, which is a over b divided by c over d equals a over b times d over c, right? So we can go ahead and this we keep the same, so we have x minus 4 over x minus 2 times x plus 2, and then we have times, and we can flip this over, so this gets flipped over. We have x plus 3 times x plus 2 over x minus 4 times x plus 1. And we bring it together. We have x minus 4 times x plus 3 times x plus 2 over x minus 2 times x plus 2 times x plus, or minus 4, excuse me, times x plus 1. Now, the factors that cancel out are x minus 4, x plus 2, and then I believe that's it. So in reality, this would be x plus 3 over x minus 2 times x plus 1. This would be your final answer in factored form. If you wanted to, you can go ahead and multiply out the bottom. So you have x squared plus x minus 2x, that's minus x minus 2. So either way, this would be your final answer. These are two possible final answers. So yes, you see how they got x plus 3 over x minus 2 times x plus 1. Now, adding and subtracting rational expressions, right? You have to know how to do these, because once you get to calculus, you have to know how to do it. Basically, they give you like how to, so you have to know like how to do this in calculus, especially when you get to calculus 2, when you do integration by parts, or actually not integration by parts, integration by partial fractions. But anyways, you have to know how to do this, right? It's very important. So let's look at this first one. 3 over x minus 1 over plus x over x plus 2, right? Now, there are two ways to do this. Number one, you can use this rule. Okay, or you can use this rule where you say that this is BD, and then this is also has a denominator BD, and then you just go ahead and you do this, right? Either way, it gives you the exact same thing. This is called cross multiplication. So we can say the following. If we kind of color code here, we can say 3 times x plus 2 plus x times x plus 1 over x plus 1 times x plus 2, right? So this would be 3x plus 6 plus, and then we have x squared plus x over x squared plus 2x plus x plus 2, right? This equals, so we have x squared plus 4x, because it's 3x and x, and then plus 6 over x squared plus 3x plus 2. And then you can try simplifying that to see if there's any factors that cancel out. So you can factor the top and bottom, right? You can say the top is 6, and then, you know, basically you have a 4, and then you have, so two numbers that multiply to 6 and add to 4 are, so basically, it really depends, actually, well, not in my opinion, but it really depends. Sometimes you're not going to be able to factor the top and bottom, or the top or the bottom, and sometimes you are. So like for example, in this one, the top isn't factorable because we can't figure out what two numbers multiply to 6 and add to 4. We can't find two whole numbers that do that, because all we have is 1 and 6, and then we have 2 and 3. But 1 plus 6 does not equal 4, and 2 plus 3 does not equal 4, right? So we can just leave that as it is. Now the bottom is another story. The bottom, you can do, so 1 times 2 is 2, and then we have the b term, 3, and then we do, so two numbers that multiply to 2 and add to 3 are 1 and 2. And we can say that this is x plus 1 times x plus 2, right? And that would be our answer. Right, so this is exactly what they got here. X squared plus 2x plus 6 over x minus 1 times x plus 2. Oh, and actually, hold on, give me 1 second. Well, I did x plus 1 over x plus 2 accidentally. But yes, it's the same idea. I just realized I kind of messed up here, but it's the same idea that they did over here, right? They did cross multiplication, and then they went ahead and did this like that, right? Now, let's look at this. Let's look at the part B that says 1 over x squared minus 1. So, minus 2 times x plus 1 quantity squared. Or 2 over x plus 1 quantity squared, excuse me. So this one, we can factor the left term. We can say that this is equal to 1 over x plus 1 times x minus 1. And then the right term is minus 2 over x plus 1 times x plus 1, right? And then we can do what is it called? Cross multiplication. So this, so we can say 1 times the quantity x plus 1 times x minus 1, or x plus 1, excuse me, and then minus 2, and we can do this other part here, right, times x plus 1 times x minus 1, and then we can do all over x plus 1. Notice that there's 1, 2, 3 terms, so we can put this to the third power times x minus 1, right? And we go ahead and simplify this. So 1 times x plus 1 times x plus 1, that's just x plus 1 times x plus 1 minus 2, and then we have x plus 1 times x minus 1, right? Over x plus 1 cubed times x minus 1. Now, we can go ahead and simplify this further by doing FOIL method on top. Now, one way that I can do this is, since we have a times a minus 2 times a times b, I can factor out the a term. This is a, and then this is a, and this one is b, right? So in reality, I can go ahead and do the following. X plus 1 times the quantity x plus 1 minus 2 times x minus 1 over, and I can say x plus 1 times the quantity x plus 1 squared times x minus 1, right? Because I can really, in reality, if you look at this, this is what I'm doing here, right? Right? That's exactly what I'm doing. And I'm just taking out the a term, right? Like I did up here, right? And this cancels out, so then I can say, okay, well, there's not really anything left for me to be able to factor out. So I can say that this is equal to x plus 1 minus 2 times x minus 1 over x plus 1 squared times x minus 1, right? And notice there's nothing else we can factor, right? I mean, I can factor on here, I can say, well, this is just, you know, I can do this in a product of 2, right? But in reality, that's not gonna give me any, it's not really gonna do anything for me. So I can't really simplify this any further than I already have. So I can say x plus 1 minus the quantity 2x minus 2 over x plus 1 quantity squared times x minus 1. Now, I can go ahead and say that this is equal to x plus 1 minus 2x minus 2 over x plus 1 quantity squared times x minus 1, right? And I can say x minus 2x, that's just negative x, and then 1 minus 2 is just minus 1 over x plus 1 squared times x minus 1. Be careful now, because you see, I basically here, right, you cannot cancel anything out anymore. You can't factor anything out of this anymore. But once we go ahead and if we have a power of 1, we can combine this, right? That is if we have a power of 1 here, a degree of 1. We can combine this, and we can go ahead and combine all of this to get this. Now, since it is negative x minus 1, we can go ahead and factor a negative out. This is equal to negative the quantity x plus 1 over x plus 1 squared times x minus 1. Now, this is equal to negative the quantity x plus 1, and we can split this into two products, x plus 1 times x plus 1 times x minus 1, because really, this is what I'm saying. This is equal to this, okay? Now, we can cancel this term out, and I can say, well, this is just negative 1 divided by x squared minus 1, or negative 1 over x plus 1 times x minus 1, right? Either answer works. Okay. And like I said, they teach you this so that you are very prepared for calculus, because once you do derivatives, you're really going to have to know this really well. Sometimes when you do derivatives of quotients, of rational functions, you're going to have to know how to do this. You're going to have to simplify it so that it looks like this, okay? So that is why this is very important. Oh my goodness, guys, I made a mistake. I'm so sorry. I just noticed something. And if you caught my mistake, I do apologize. So, there's one thing I forgot to do. Very important. This is why you have to be very careful. And sometimes, yes, even I make mistakes. So this is actually 2x, so it's x plus 1 minus 2x plus 2 over x plus 1 quantity squared times x minus 1. And then you do x minus 2x plus 1 plus 2. And then you do x over x plus 1 quantity squared times x minus 1. So then it's negative x plus 3 over x plus 1 quantity squared times x minus 1. Or you can also write it as 3 minus x over x plus 1 quantity squared times x minus 1. Either way, they're both answers. So yes, this is why they got this part for this. Okay, so compound fractions. It says a compound fraction is a fraction in which the numerator, the denominator, or both are themselves fractional expressions, right? So in reality, it's just good to know this, because it just shows that you know, basically that we have a good sense of algebra. We know how to do this if we are ever given something like this in precalculus or in trig, right? So it's very important to know this, because once you do trig, there are going to be trig expressions where you're going to have to kind of know how to simplify things like this, right? So we have x over y plus 1, right? Over 1 minus y over x, at least I think. Okay, so the first thing that I would want to do is I want to simplify the top. That looks like we can simplify it, right? You have x over y plus, and one of the things that anytime you see a +1 on here, you want to go ahead and make it so that it's 1 over 1, so that you can make it the same denominator, right? So this is going to be, and it's going to be all over, and it's going to be 1 minus y over x, and the bottom we will simplify it in a little bit. You have x plus y over y. And then once we look at the bottom, 1 minus y over x, well, that's just 1 over 1 minus y over x. So we want to get the same denominator. We do times x on top and bottom. We go ahead and do x plus y over x minus y over x. This is equal to the following. Now that you have this, you can do a division, right? Dividing fractions, you can say. It's just like if I say a over b divided by c over d. Well, I can go ahead and say that this is a over b divided by c over d, which is just a over b times d over c. I always like to, whenever I'm given something like this, I like to write it out as a division of two fractions. That always helps. And then I go ahead and use the dividing fractions rule, right? This is equal to x plus y over y times, I'm going to flip this over, so x over x plus y, over x minus y, excuse me. So then this gives me x times x plus y over y times x minus y, right? I mean, you could always do it like x squared plus yx, or xy over xy minus y squared, but you always want to make sure that you put it in the factored form so that, you know, so that the professor can see that, yes, you know that it's factorable. And sometimes in multiple choice, they don't give you, they're always going to give it to you in factored form. So that's why you want to make sure that whatever answer, like any problem in this video, you want to make sure that you can factor. Always want to make sure that you can factor before you put the final answer. So yes, you see how we got it's x times x plus y over y times x minus y, right? Let's see here, what else? This is another way of doing it. In reality, yeah, I mean, I don't see how they did it this way, but you can look at this, and if this makes more sense to you, then that's great. But I honestly wouldn't do it this way, because, yeah. Okay, so simplifying a compound fraction, 1 over a plus h minus 1 over a all over h. This looks really familiar, and it says the next two examples show situations in calculus that require the ability to work with fractional expressions. You're going to do this so much in Calculus 1. This comes up so much in Calculus 1 when you're doing the definition of a derivative using the limit definition. So yes, this is really, really, really important. So we have to know how to do this for Cal 1. So we have the following. And I believe I did this in a previous example, or a previous video that I did a few days ago. 1 over a plus h minus 1 over a all over h. So looking at this, we can subtract this out, right? Now you can either use the what is it called? The cross multiplication rule, or you can use like when you do like this, right? As long as you get the same denominator. But also remember that you have an over, like you're dividing by h. Remember that, because sometimes in these problems, sometimes it's very easy to forget to divide by h, okay? So we're going to go ahead and do it. We have 1 times a minus 1 times a plus h over a times a plus h. Now you can do it the other way. You can do it this way, where you say, well, this is just a times a plus h, and then also this one is a times a plus h. So to get from a to a times a plus h, I just multiply times a plus h. And then what I do to the bottom, I do to the top, so it's 1 times a plus h. This is a plus h, and then I say times a over here. So 1 times a is just a, right? And then I can say, okay, well, this is just a minus, and then I'm going to put parentheses because this is an expression in and of itself. A plus h over a times a plus h. So then this gives me a minus h over a times a plus h. This is equal to negative h over a times a plus h, which is equal to negative h over a squared plus ah. Either way, these are two possible answers. Now, in cross multiplication, you would do cross multiplication, and then you would just go ahead and work out the top and bottom. You can say a minus h over a times a plus h. This is why I like cross multiplication better, because it's a lot faster, okay? So then these two cancel out, and we get negative h over a times a plus h. This is a possible answer, and this equals negative h over a squared plus ah, right? That's also a possible answer, okay? All right. All right, so let's do this one. Example 8, simplify 1 over x squared to the 1/2 minus x squared times 1 plus x squared to the negative 1/2 all over 1 plus x squared. Okay, so let's go ahead and do this really quick. Okay, so this looks like a very similar example that we did in the previous section. If you look at this previous section that we did an example that looked a lot like this, except it was more it was more with how do I say it? It was more with multiplying. At least I think. But anyways, in 1.4, it's more in 1.4, it's the opposite. It's dividing, right? At least I don't think I did one of these in the previous section. All I did was factor out, right? But here it's asking us to divide this out. So it's kind of similar, but it's dividing, right? So no, this is not with polynomial long division. Do not get confused. Do not do that. It's going to make it very complicated. So I would factor the top, right? So again, in reality, you have, so you can say 1 plus x squared to the negative 1/2. Again, take your lowest term and then simplify it. So then you have times the quantity 1 plus x squared to the first power, because that'll give you 1 plus x squared to the 1/2, right? And then basically what I'm saying is that these two, so basically these two multiplied together will give you this term, right? And then I say minus, so then it's going to be minus, and since it is negative 1/2 this time, we're just going to put 1, right? Because that's exactly what we got. So it's just going to be minus x squared. Since x squared is already multiplied by 1 plus x squared to the negative 1/2. And we can verify that this is true, really. You can always check by distributing it back in. And this is over 1 plus x squared. And this is raised to the first power. So really, you're going to have 1 plus x squared over, or rather it's the negative 1/2, over 1 plus x squared to the first power times 1 plus x squared. And then since it's to the first power, we can just go ahead and leave it the way it is without the parentheses, right? So then we can say minus x squared. Like basically bring down, or like just put in the negative x squared that we have left over. And then we have 1 plus x squared to the negative 1/2 times 1 plus x squared minus x squared. So in reality, these two cancel out. We're just left with 1 plus x squared to the negative 1/2 times 1, which is just over 1 plus x squared, right? Raised to the first power. We want to put a first power, like a power of 1, because at the end you're gonna have to use laws of exponents, right? So this is just 1 plus x squared to the negative 1/2 over 1 plus x squared to the first power. Now this, you're gonna have to use the laws of exponents. Remember that a to the n over a to the m is just a to the n minus m. Now if we have a to the negative n over a to the m, this is a to the negative n minus m. So this is just going to be 1 plus x squared raised to the negative 1/2 minus 1 power. This is 1 plus x squared raised to the negative 1/2 minus 2/2 power. So this is going to be 1 plus x squared raised to the negative 3/2 power, right? And we can simplify this a little further. Remember that anything that has a negative exponent or a negative power right here can just be the reciprocal. This is what I mean by reciprocal, is that if I have a to the negative n, I can just say this is 1 over a to the n. Same thing here. I can say that this is equal to 1 divided by 1 plus x squared raised to the 3/2 power. Right? And that's exactly what they got over here. So that's how you do it. We're not going to look at solution 2 because, yeah, I mean, you can look at this part, but I'm not going to go over it because obviously I don't want to make the video very long. Okay, so example 9, it says rationalize the denominator. So there's, okay, so when you have a a rational in the denominator, you always multiply by the conjugate. Now, if the conjugate is of the form 1 divided by a plus the square root of b, that means you're going to multiply by the conjugate a minus the square root of b, right? So if I have like x over, then that means I'm going to multiply by a minus square root b over a minus square root b. Similarly, if I have x over a minus square root b, I'm going to multiply by the conjugate to get rid of the rational on the denominator. Okay. That's all that's saying. In reality, this one here is saying, so if we do 1 over 1 plus the square root of 2, we can rationalize the denominator. We can say that this is equal to, we're going to multiply it by 1 minus the square root of 2, right, on top and bottom. So then this becomes 1 over 1 minus the square root of 2 over 1 plus the square root of 2 times 1 minus the square root of 2. I want to give you a really quick warning. Do not cancel this out, because then it's going to give you what you started with again, right? Do not cancel it out. You want to go ahead and leave. So basically, multiply the top, and then you multiply the bottom as well. So you're going to have 1, and then minus the square root of 2 plus the square root of 2, and then minus the square root of 2 quantities squared, right? This will give you 1 minus the square root of 2 over, and then this will be canceled out. This will be 1 minus 2, and it's just going to be 1 minus the square root of 2 over negative 1, which is really just negative 1 plus the square root of 2 over 1, which is negative 1 plus the square root of 2, or you can also write it as the square root of 2 minus 1. These two answers can work, right? Yeah, that's exactly what they got here. Now, this one, you do this, like I said, you do this also in calculus. When you do the definition of a derivative for a square root function, you're gonna have to know how to do this. So the square root of 4 plus h minus 2 all over h, right? This is equal to, and you can do like the conjugate. So you're going to multiply by the conjugate, 4 plus h plus the square root, or plus 2, excuse me, over the square root of 4 plus h plus 2, right? So then this gives you the square root of 4 plus h, and if you look at it, it looks a lot like a plus b times a minus b, right? So you can do that. You can say the square root of 4 plus h squared minus 2 squared. This is to save time, right? So that you don't have to do like FOIL method. And then the bottom, you can leave, like, you can basically leave it unmultiplied. So you can say h times the square root of 4 plus h plus 2. Excuse me. So this gives you 4 plus h, because the square root cancels out, and then minus 4 over h times the square root of 4 plus h plus 2. So now you see why what you never want to do in this type of problem is you never want multiply the bottom part. You never multiply it out because your h most likely will cancel out. You're going to get an h divided by h times the quantity, the square root of 4 plus h plus 2. And then this cancels out, and you're left with 1 over the square root of 4 plus h plus 2. Okay. Oops. All right. So yes, that's what they got here. Okay. Okay, so these are just avoiding common errors. This is what I was going to say, or I believe this is the last part of this section, at least I hope. So yes, or actually yes it is. So one of the common errors that a lot of students do, and you really want to try your best to avoid these errors because you can get confused. A lot of people say that, for example, this one here, yes, anytime you have a times b quantity squared, this is a squared times b squared. Yes, that's correct. However, when they do addition, that's not the case. A lot of people believe that a plus b quantity squared is a squared plus b squared. No, it is not. It's a squared plus 2ab plus b squared, okay? Similarly, people think that the square root of a times b equals the square root of a times the square root of b. Yes, that's true. Yes, because the square root of a times b, when it's multiplied, it's the square root of ab, so you can separate it. However, and it's such that b does not equal, or b is greater than or equal to 0, because remember I said that any square root cannot be negative. Okay. However, people think that the square root of a plus b equals the square root of a plus the square root of b. No, that is not true, because when I say the square root of 2 plus 3 equals the square root of 5, that's not the same as if I said the square root of 2 plus the square root of 3 equals square root of 5. No. And you can check that with a calculator. So that's why they give you this property. Now this one says the square root of a squared, b squared is ab. Yes, that's true. That's true because the square root of a squared is a, and the square root of b squared is b, so it's ab. However, and I don't know how this one can, I do believe that maybe there are people that do believe this, but people believe that the square root of a squared plus b squared equals ab, and no, it's not, because it's not the square root of a squared plus the square root of b squared. That's not true. This is not true, so you want to avoid this, right? 1 over a times 1 over b equals 1 over ab. Yes, that's true. Yes. Because you just bring them together. However, 1 over a plus 1 over b is not 1 over a plus b. We did that when we did adding rational expressions. You cannot, it's like when they teach you in elementary school how to add fractions. You cannot just say 1/2 plus 1/3 is 1/5, because you have to have the same denominator. ab over a is b. Yes, it is, because you can, again, the product and the quotient, they cancel out. So you can cancel this out and get b. However, a plus b all over a is not b. You cannot do this. This is not true, right? A to the negative 1 times b to the negative 1 is a times b to the negative 1. Yes, that's true. However, a to the negative 1 plus b to the negative 1 is not a plus b to the negative 1, because, again, anytime you have addition, you cannot distribute the exponent, okay, the power. And this is just a few more problems for this, but yeah, I mean, we already did all of these kind of things, and this is just, more practice, I would say. So that is the that is the last part of this section. So that concludes 1.4. If anybody has any questions, please let me know right away. I know I did this section pretty long because a lot of these examples, yes, they do require that you understand I want to make sure that this is very well understood. I don't want to just go on these YouTube videos or make these YouTube videos and just say, oh, well, you can just look at this and this is how it is. I like to explain it very, very clearly. So yeah. But yes, if anybody has any questions, you can let me know. If you have any problems that you need me to work out, I can also do that. But yes, this is it for this section, and in the next section, we're gonna do equations, which is 1.5. So yeah, that is it for this section, guys. I hope this helps, and I hope that you found this very helpful. If anybody has any questions, you can let me know. Also, please like, comment, and or subscribe to my YouTube channel. And I will see you guys next time. Bye, guys.